All right, in this video, I want to talk through number 9 because there's a lot of key concepts that show up kind of like in multiple choice questions, perhaps on our test, perhaps on the IB exam, but it's the concepts that number 9 is focusing on. So normally when we have like a golf ball problem, when we fire something up into the air horizontally, when we fire something up into the air at an angle, we know the initial velocity that we fired it. In the example that we did in our notes, it was 48 meters per second, and then someone tells us the angle. So then the first thing that we have to do is we have to find the x and the y components, like what is the x component and what is the y component. Well, in number 9, we're kind of doing things backwards. So in number 9, they're not telling us the initial velocity and the angle. They're telling us the components. So an object is fired with a horizontal velocity of 20. So this arrow here is 20. So I'm going to write down Vx equals 20. And a vertical velocity of 29.4. So this angle or arrow, I'm going to make it a little bit taller since it's bigger than my 20. So the vertical, which is the y arrow, is 29.4. So the first question is determine the initial velocity and angle at which it was fired. So I'm just kind of like making this into like a triangle here. So I'm going to redraw it over here so it's a little bit easier to see. So we have the x component is 20. We have the y component is 29.4. And we're kind of just pretending that we have taken a small enough segment of this parabola that for all practical purposes, we can assume that this line is straight. So this line is going to be VI, and we are looking for theta. So since it's a right triangle, I can just use Pythagorean theorem to find VI. So I'm going to go 29.4 squared plus 20 squared equals, and then square root that. And I get 35.56. So 35.56 meters per second. So that's the velocity that we are firing this object up into the air. And then the angle, again, I'm just going to use tangent. So tangent of that angle would be the opposite. So 29.4 over 20. 29.4 divided by 20. Then I'm going to go second answer, and the angle is 55.78 degrees. 55.78 degrees. Okay, so let me continue with the arrows, what we know about the arrows. So one of the key concepts is that the x component always stays the same. So Vx equals 20, Vx equals 20. At the very top, I'm going to write it down. Vx equals 20. This one is 20. This one is 20. This one is 20. All right, so what is the x component of the velocity of the object at the top of the path? 20, because it never changes, 20 meters per second. All right, what is the y component at the top of the path? Well, if I fire it upward at 29.4, in the y direction, we're going to get slowed down by gravity every second. So let's assume this is 1 second later. So 29.4 minus 9.8 is going to give me 19.6. Then I'm going to go another second. I'm going to subtract 9.8. That's going to give me 9.8. Then I'll go another second. So it looks like it took me 1, 2, 3 seconds to get to the top. And now 9.8 minus 9.8 is 0. So the y component of the velocity at the top of the path is 0. And then on the way down, it's positive 9.8, 19.6, and back to 29.4 again. But this is the key question that people ask all the time. It says, what is the velocity of the object at the top of the path? And we always just kind of have this natural inclination that the velocity at the top of the path is 0. but it's not, because when you have projectile motion, you always have this x component that never goes away. So the velocity at the top of the path is always going to be equal to the x component. So in this case, it's going to be equal to 20 meters per second. Now you have to compare and contrast that to, what if I fired something straight up into the air? So if it went straight up and then it fell back down, the velocity at the top of this path is 0. But when you projectile motion something, you give it that little x component at the start of the story, and that x component stays with us the entire time. And so it's still there at the top of the path, even though the y component has turned to 0. That's just kind of a tricky question there. What is the velocity of the object at point P? So here's point P. So I got to think through this. Well, I know that this is 20 in the x direction, and this was a y component of 0, 9.8. This is 19.6. So I have a 20 to 19.6. I can kind of parallelogram those. Well, a squared plus b squared equals c squared. And I can just number crunch that to find the velocity. So 20 squared plus 19.6 squared. And then I'll square root that. That is going to be 28 meters per second at point P. So 28 meters per second. Sketch the direction of the acceleration at point P. So some people get psyched up into the picture. I kind of scribbled in my picture so much, I'm going to draw a new one. And they start to look at different positions and think that, you know, that something is pointing up, something is pointing down, but quite simply, the acceleration acting on anything that's in free fall motion is just gravity. So it's always going to be 9.8 down, 9.8 down, 9.8 down. It doesn't matter where the object is. It's always going to be 9.8 down. So state the direction. We'll just put a down arrow there. All right. I hope that helps with that one, because I know the questions were a little bit tricky.